Okay, so this is part three. So we're talking about do loops now. So again, it's just going to allow us to repeat something over and over again. The only question is, it just gives us a different way to decide when to stop. That's the only difference. So a different type of loop structure is a do loop, also just called do loop for short. This type of loop allows repeated execution of a set of statements also. But with loop termination based on a test, a conditional test. Anyway, it just gives us a different way to stop. Not on the value of a built-in loop index. So what he means by that is, here, we know how many times we're going to repeat this loop, right? We're going to go from 0, then we're going to do 1, then we're going to do 3. So we're going to actually do it 11 times, right? So we know how many times we're going to do it just by what's defined up here. But in a do loop, let's look at an example of a do loop. Do we have an example? Okay. So here's a problem he wants to do. Now, actually, if you think about it, we just did this problem in the for loop. The first for loop we used, we added up all the numbers between 1 and 10, right? So if n is 10, we just did it before, right? We said 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So we did that, okay? But now, suppose we want to let the user enter a number n, and then we want to go all the way up to that number. So if the user enters 10, then it would be the same calculation we did before. But so suppose the user entered 15, then we'd want to add up all the numbers between 1 and 15. So in that case, we could use a do loop. Actually, we could also use the for loop, but we're going to use the do loop. So we're going to build a program that where the user puts in a number, and then we're going to sum from 1 up to that number. Let's see. So we're going to actually do it in a number of different ways. But first, let's do it. I think we're going to do it. Well, anyway. So here the user is going to enter the number, and here our result, our calculation is going to appear after we do the calculation. So program for summing the integers from 1 to n. Please input a number value for n. Okay, so let's see this. Okay, so first he does it using the for loop. So let's look at that because we've already seen how to do that. So let's try it. So we're going to have this button, and so when the user clicks on this button, this code is going to be run. And we're going to initialize the variable s equal to 0. And I'm sorry, we're going to define n and s up here as integers. And we're going to initialize s equal to 0. And n is going to be what the user puts in here. So it's going to be the value of this box will be called the text input, txt input. We're going to get the text of that, and we're going to use a function called val to get to convert that to a number, and that will be n. Okay, so n and s, after the user enters a number in here, n and s will both be set. And then this will go down to here. And so for I as integer from 1 to n, so before we had 10 there, but now we're putting n, but n will have a value, so we can put n there in step 1. So if the user put in 15, then this would say from 1 to 15. And then what do we do? Well, this was the shorthand for what we did before. S equals s plus 1. That's basically what this means, right? This means s equals, a simpler way of writing this would be s equals s plus I, right? So, but this is a shorter way of writing that. So we're just saying the sum is equal to what it was before plus I. Okay? and then output the value of s at the end. So put that here. Okay, so that's using the for loop. Now, let's look at the how it's done with the do while loop. So same thing, we want to do the same thing, but we want to use the do while loop. So let's look at it here, and then we'll go back and discuss what the elements of the do while loop are. But let's just read it, see if we can figure it out. So we still have s equals 0, and n equals the value that the user puts in here. Now this is different than before. We didn't do this. Dim I as integer equals 1. That was different than here. We didn't say dim I equals, what was it? Dim I as integer equals 1. We didn't do that here, right? We used I, but we used it here. So a little bit different. So in other words, the syntax is a little different here, but we are going to be using some I. It's probably going to have the same purpose here as it is in the do loop, but we don't here. I didn't say this before, but actually we're actually when you write this for I as integer equals 1, you're actually defining I. You're declaring I. This actually declares I, and I is actually a local variable here within this loop. But I didn't say that, but that's true. So here, though, we're defining I outside of this loop. Okay, so we do that. And then, here's the idea. Remember, the user's going to enter a number in here, and then this says, do these statements. So do these statements. What are these statements? Let's look at the statements first. S equals plus equals I. So that's the same thing. We're adding, we're incrementing the sum by I, right? So we're doing that over and over again. So that's exactly the same as before. But here, we're incrementing I as well, right? This is used. Remember, this is remember, I plus equals 1 is the same thing as I equals I plus 1. So we're just incrementing I by 1 when we write this. So here, we're just incrementing I by 1 inside this loop. Okay? So what we're doing inside the loop is we're adding I to the sum, and then we're incrementing I. Now, we didn't do that before. Here. We didn't do that before, right? We didn't increment I by 1. It was done automatically for us when we write this line here. That's what this line does for us. It increments I by 1 each time we go through. But in the next loop, it doesn't do it for us. So we have to explicitly say what how I should be incremented, and we say it here. We say increment I. So you have to do that in the do while loop. You don't do that in the for next loop. Okay? So do you see how this happens? What happens? So let's say it again. We declare I in this one. We didn't have to do that in the for loop, but we have to do it here. And then we write do while, and let's forget about this for a minute. And in the first iteration, what happens? S was originally 0. I is 1. So it becomes S is now 0 plus 1 or 1. And then what happens here is I gets incremented, so I will now be 2. Okay? And then we go back and we do it again. And then we come back and we do it again, and we do it again, and we do it again. Now the question is, when do we stop? Because this is different than this one. This one says when we're going to stop. It says we're only going to do it n times, right? Or like we saw before, 10 times, or whatever it was, 11 times. Okay? But here, there's nothing telling us when to stop, unless we consider this part as well. Okay? So this part tells you when to stop. So you do it, you keep repeating this, as long as this part is true. So as long as I is less than or equal to n. Now remember, the user is going to put in n, so if the user put in 15, then n would be 15. And so as long as I is less than 15, we're going to repeat this. But as soon as now see, I get, so suppose finally we did it, and I is now 15. It says I is less than or equal to 15, so we're going to do it again, right? Because less than or equal to 15, if the user put in 15. So we do it again. So this would get incremented by 15, and then what would happen here? I would then become 16. So would this get run again with I equals 16? We come back up to here, and we check is 16 less than or equal to n, but n was 15. So is 16 less than or equal to 15? Of course, no. So we don't run it anymore. So this tells you when to stop in a do-while loop. Okay? So we just keep repeating it until this condition is not satisfied. Okay? And that's the way the do-while loop works. Okay, let's go back to the previous slides and check out the details or how he expresses all of this. But you can see how it works. Okay?